In this video, we will be talking about electrolytes. This continues our learning objective for describing aqueous solutions. So when ionic compounds, strong acids, and bases dissolve in solution and become aqueous, they actually separate into separate cations and anions. And so if you started with solid silver nitrate, for instance, this is composed of silver plus cations and nitrate 1 minus anions. And once those are dissolved in water, then they are separate cations and anions. So we have our separate cation and anion once it's aqueous. And so we use this AQ symbol to mean dissolved in water, aqueous. And that means solid. So like if you took solid silver nitrate and dissolved it in water, you would have separate cations and anions. The nitrate doesn't separate further because it's held together by covalent bonds. By covalent bonds. So this ionic bond gets split. But covalent bonds are not broken. So the covalent bonds are not broken, ionic bonds are when it's dissolved in solution. So if we started with something like calcium hydroxide, in order to have this be neutral, we needed to have 2 hydroxide ions. And so those 2 hydroxide ions turn into separate hydroxide ions. So 2 separate OH minus ions. So do not do something weird like this. That's not what we have. That 2 needs to come out in front to mean it's 2 separate OH minus ions. This process of splitting apart into ions is known as dissociation, meaning they're not socialized together anymore. They're not associated with one another. When you do have charged ions in solution, then that makes it an electrolyte solution. Electrolyte solutions are aqueous solutions that conduct electricity. Substances can either be classified as strong electrolytes, weak electrolytes, or non-electrolyte. So Gatorade is known for having electrolytes, and so that means essentially that it has salts dissolved in the water, like ionic salts dissolved in solution. We will be talking about what makes something a strong electrolyte, weak electrolyte, and non-electrolyte, so that we can classify our compounds into these 3 categories. Strong electrolytes. To identify something as a strong electrolyte, you're looking for any ionic compound or something that's a strong acid and or a strong base. So on your green sheet, on your green reference sheet that you picked up in lab, it has a list of strong acids and a list of strong bases. If it's not on the list of strong acids and strong bases, it is weak. So only acids and bases on green sheet are strong. If not strong, is weak. If you notice on the green sheet, all of the strong acids have H listed first in the chemical formula and followed by one of the halogens or some polyatomic ions. Not fluorine though. Fluorine hydrofluoric acid is a weak acid. And strong bases all have the OH minus ion to them. So all of the bases have to have hydroxide ions, and strong acids have H plus ions first. So ionic compounds are strong acids are strong bases are strong. If it is an acid that's not on the green sheet, then it's not a strong acid. That's what we've learned so far. So that's how you can tell if something's a strong electrolyte. But what does a strong electrolyte mean? A strong electrolyte means that it completely separates into cations and anions. There will be no neutral ionic solid left. Like if it exists in aqueous solution, then it's going to exist as separate ions. In this solution, there are no intact formula units. It's either all ions or it's not in solution. So strong electrolytes completely separate into their cation and anion. Completely fall apart. Later on in the semester, we will learn about solubility rules and determining if something's soluble or insoluble. Insoluble doesn't mean that nothing dissolves, it just means that very little is dissolved. But what is dissolved is completely ionized for an ionic compound. Non-electrolytes are the complete opposite. So non-electrolytes, the particles in solution, are all neutral particles. And so when we're looking for non-electrolytes, we're looking for molecular compounds because molecular compounds are held together through covalent bonds. And those covalent bonds are not broken when the molecular compound dissolves in solution. So this is glucose's chemical formula. And if we put solid glucose in solution, it's going to stay as glucose. It's just not going to be aqueous. There's no ions formed here. So if you look at chemical formula and you can identify it as a molecular compound, then you'll classify it as a non-electrolyte. Weak electrolytes are in between. And so weak electrolytes exist mostly as intact molecules, but then there's a few ions. And so here we will look primarily for weak acids or weak bases that are not ionic, because all ionic compounds are strong. So if you have an ionic compound, it's going to be strong. But if you have an acid that's not on the list, then you'll definitely classify it as a weak acid. And then we'll learn more about organic acids and organic bases later on, or maybe in another course. Not sure yet. So for now, we have acids have H listed first in the chemical formula, and bases have the hydroxide ion. So in summary, we have our strong electrolytes are going to be any ionic compound, strong acids or strong bases. Weak electrolytes are going to be weak acids, weak bases that are not ionic. And non-electrolytes are going to be covalent / molecular compounds, whatever you want to call them. Here's a practice problem for you. So go ahead and pause the video and try to work this out on your own. It will be good practice for identifying what type of compound it is. I left a column for you there. Think back to your nomenclature module and what we learned for identifying what type of compound it was based on the chemical formula, and you can fill this in. Unpause the video when you are ready to continue. Okay, so sodium sulfate, that's a metal with a polyatomic, and so that's an ionic compound. Ionic compounds are going to be strong electrolytes. We have H listed first, so it's an acid, but it is not on the list of strong acids, so it is a weak acid. And weak acids are weak electrolytes. Now we have H listed first again, so this is also an acid, but sulfuric acid is on the list of strong acids, and so this is a strong acid. I'm just going to write green sheet there so you can reference your green sheet to see the list. Since that is a strong acid, it's going to be a strong electrolyte. This is an ionic compound. It is also a strong base. So if you classified it as a strong base, you're also correct in that. So that strong base and ionic compound is going to be strong electrolyte. And then this is carbon listed first, so it's not an acid. This is just some kind of molecular compound. And molecular compounds are going to be non-electrolytes. Come on. So that concludes our video about electrolytes. Let me know if you have any questions.